In this lesson, we'll be proving the proportionality theorem. So we've went over this theorem in the previous videos, and it said that if I've got a triangle with three vertices, and I've got this line here that is joining two sides of this triangle. So the line DE here is joining this side and this side, but then it doesn't necessarily have to pass through the midpoint. So basically D is not the midpoint of AB, and E is not the midpoint of AC. It doesn't have to be the midpoint. As long as this line here is joining two sides of this triangle, therefore we come to conclusion that AD, the ratio of AD to DB must be the same as the ratio of AE to AC. So if I take this side, I'm going to take the side that is opposite to it. If I take this side and I take the side that is opposite to it. And if I take this one divided by this one, I'm going to get this one divided by this one. So that is what the proportionality theorem says. So we've just stated the theorem, but in this lesson we are going to prove it. So the first thing that we're going to do is to construct lines. Like many proofs in Euclidean geometry, we need construction. So you must draw lines before you proceed with your proof. So I'm going to draw a line from here to here and call this line K. And then I'm going to draw the other line from point E to that point, and I'm going to call this line H. Now, I'm going to further join these two. I'm going to use a different color for that. So I'm going to join this one, and I'm also going to join these two. Okay. So the first thing which I'm going to do is I'm going to look for triangles which have got the height of H. So if you look at this triangle over here, this triangle here has a height of H, which is represented by this blue line. And similarly, this triangle here also has the height of H, which is represented by this blue line. I'm going to check the ratio of the areas of those two triangles. But because we know that the area of a triangle, in general, the area of a triangle is given by half multiplied by the base multiplied by the height. So now I'm going to say the area of triangle AED over the area of triangle we said this triangle BED. Now these two triangles, if we look at them carefully, this triangle here which we drew before and this triangle over here, they share the same vertex at point E. Triangles which have the same vertex at a point, they have the same height. So here we can say that the area of triangle AED is equal to half multiplied by the base. The base of that triangle is AD times its height, which is H, divided by the area of triangle BED. So the area of triangle BED is half. The base of triangle BED is BD or DB, or that doesn't matter, multiplied by the height. Half will cancel the half, H will cancel H, and we come to a conclusion that is equal to AD over DB. Okay. And then, furthermore, we are going to go to the other side. Now we're focusing on a height of H. Now we're going to focus on the height of K. So, using a different highlighter for that, if you look at this very same triangle, now I'm going to call it ADE, right? Triangle ADE, it has a height of K. right? It's the same triangle, just viewing it from the different perspective. Triangle ADE is the same as triangle AED. So this triangle ADE has got the height of K. And similarly, this triangle here, which is CED, also has got the height of K. Why so? It's because this triangle and this triangle here, they share the same vertex at point D, and therefore they should have the same height. So I'm going to check the area of those two triangles again. So these lines have to be parallel for this proof. Okay, I forgot that. So you must draw DE such that it is parallel to BC. It must be part of your what you should know. So the first step is to construct DE such that it is parallel to BC. Then you draw two lines from D to somewhere between line AE, and then from point E to somewhere between line AD, and then you join B and E, then you join D and C. Now I'm going to take the ratio again, the area of triangle. Now I'm calling this triangle ADE. Triangle ADE really doesn't matter. Let's just keep the same thing, AED, and I divide by the area of triangle CDE. Now, what is the area of triangle AED? It's going to be half multiplied by the base. Now our base is AE, right? So I'm looking at this triangle over here. This is the base, this is the base, and then the K is the height. So we've got half the base, which is AE, multiplied by the height, which is K. I divide by half multiplied by. Now I'm on the area of triangle CDE. Triangle CDE is this one. Because it shares the same vertex D with triangle AED, it shares the same height with it as well. So the height of triangle CDE is also K. So here, the area of triangle CDE is half multiplied by EC, which is the base, multiplied by the height, which is K. Half will cancel half, K will cancel K, and then I've got AE divided by EC. Now, I need to look at something. If you look at these two triangles, triangle BED and triangle CDE, there's a very important theorem that triangles which have the same base and lie between parallel lines, they have got the same area. So these two triangles here, this triangle, let me decrease the size. So this triangle over here and this triangle over here, they have the same base, right? They have the same base, which is DE. And these triangles, they lie between parallel lines. So what can we say? We can say that the area of triangle BED is equal to the area of triangle CDE. The reason for that, same base between parallel lines. Okay. Now, BED is equal to CDE. But then we know that even the ones on top, this triangle AED and this one is the same triangle, right? We just use a different orientation. Now we can conclude that these two fractions are equal. Now, if this was to be the first fraction and this to be the second fraction, then the fraction of this will be equal. Then we should say that 1 is equal to 2, right? Now, after stating that triangle, the area of BED equal to the area of CDE. Therefore, I've got something equal, let's say x over y, divide by x over y. These things will be equal, right? So I'm going to equate 1 and 2. I'm going to say that the area of triangle AED divided by the area of triangle BED must be equal to the area of triangle AED divided by the area of triangle CDE. Now, this implies that what is this ratio? AED over BED. It's equal to AD over DB. And what is this ratio? AED over CDE. It's equal to AE over AC. Now, we have reached to this conclusion here. And it looks like exactly what we were required to prove. That AD over DB is equal to AE over AC. Now, this result is what we call the proportionality theorem. This result is called the proportionality theorem. Okay, so it states, now looking at this triangle here, a line segment DE joining two sides of the triangle and parallel to the third side divides those two sides into sides which are proportional to each other. So it says that if I have line DE is drawn in such a way that it is parallel to BC, and this line DE, it joins this side and this side. It joins this point and this point. Therefore, it's going to divide these sides. If this was to be called side 1, side 2, side 3, and side 4, it divides these sides in such a way that the ratio of these sides are proportional. So S1 over S2 is equal to S3 over S4. Now, note that S1 is not equal to S3. We are not saying that S1 is equal to S3 or S2 is equal to S4. We are saying the ratio of those are equal. So I can take the first pair. If I take S1, I divide by S2, I'm going to have S3 divided by S4. Similarly, I can take this one side, divide by the whole of that. Even this side, I must take this one, divide by the whole of that. So to illustrate that, this theorem also says that I can take S1 divided by S1 plus S2 must be equal to S3 divided by S3 plus S4. As long as I'm picking sides which are opposite to each other, then this theorem holds. So this theorem is what we call the proportionality theorem. So the first thing is to draw. If you didn't construct line K and H or join B, E, and DC, you are not going to have all of this, because what are you going to calculate there? You won't have triangles. So just know that the first step is to do construction lines, and then the second step is to label your things accordingly, and then use this ratio here. Now after that, come to a conclusion that the area of BED and the area of CDE are equal. If they are equal, what is the reason for that? For every statement you make in geometry, you must give a reason. Same base, parallel lines. Triangle that lie between this, that have the same base and they lie between parallel lines, will always have the same area. And then you equate the two fractions, and the result is the prop theorem. So if they say state the prop theorem, you must state it that a line segment drawn in such a way that it cuts or it connects the two sides of the triangle, the very same line is parallel to the third side, then that line divides the two sides into sides which are proportional to each other. Thank you for watching.